Hey everyone, it's time to start talking about internal forces and moments inside of a beam. And what we want to kind of return to before we get into internals is the fixed support. So here's a beam that's attached to a wall, and that wall is going to be a fixed support. And I've exerted a force F2 and a force F1 on the beam at some locations. And the internal support then counters these forces, so it's going to supply a force in the x direction, it's going to supply a force in the y direction, because this is all in equilibrium, and it can do that. And this is strictly two-dimensional. Let's keep it nice and easy. And then it also applies, the fixed support also applies a moment m. And I've drawn that in the counterclockwise direction. It's arbitrarily in the positive direction. Turns out that's the correct direction here. But I always put it in the positive counterclockwise direction. If I'm wrong, the mathematics will give me a sign error, and it tells me it's in the other direction. Not a big deal. All right, but what we want to look at then is what happens inside the beam. So we're going to imaginary cut the beam at some location. All right, so imagine, if you will, that I've got this beam here, this post, and I can exert forces on this beam up and down or left and right. And what I'm interested in is what goes on inside at some arbitrary location. Next class you take when you do mechanics of materials, you're going to cut this beam, imaginary cut this beam, and you want to know what's going on inside the beam, because you want to see what the forces are, what the moments are. Because if you're manufacturing something, you kind of need to know what's happening inside, or if you're building a building, you want to know what's going on inside, or the wings of an airplane. Lots of different applications here. All right, in some cases, the beam might even bend, and then the forces at the bottom and the forces at the top are very different. And if it's hollow, like this is hollow, then along these edges, those forces and moments, we're going to want to know what those are, what's going on in there. And so what we do is we make a cut at some arbitrary location, doesn't matter where. In fact, in later videos we'll do a variety of locations and take a look at what's going on. But the beam, basically the structure of the beam itself is a fixed support, right? So if let's say this is over here, if I pull down on this, then this is acting like a fixed support at the center point. It's applying forces in the x and the y direction, and it's applying a counter moment, right? Because this is trying to twist it in the, what would that be? That would be the counterclockwise direction for you. So this has to apply a counter force in order for it not to break, right? It's not breaking. And so what's going to happen then is there's going to be a force acting at this cut, right? This is an imaginary cut. And the axial force is oftentimes labeled with a P. And then there's going to be an up and down force that has to come into play. And by convention, I'm going to call that V. And if I'm looking at the cut and everything to the right, then I'm going to label that with a V. And that's for the vertical force, or the shear force. And then there's going to be a moment also applied in here. And since the cut is on the left side of the beam, then that's going to be, by convention again, that moment's going to be counterclockwise. In general, I'm going to do everything on the other side because I like it better. But it doesn't matter. And the convention goes in the reverse direction for those. All right, so, and we're also going to ignore the what we call the axial force, P. We're not going to look at that in very much detail in statics. Now, when you get into mechanics materials, you're going to look at that quite a bit. But we're not going to worry about it too much in this statics class. But it applies an X force, a Y force, and then a moment. And that's what a fixed support does, and it's capable of doing that, and so it will. And then what we'll be interested in knowing is what's going on with all of that, depending upon where I am on the beam. The other thing we want to keep in mind is Newton's third law. So if I look at the other side, so if I look the same cut, same place on the cut, then Newton's third law says equal and opposite force. For every force, there's got to be an equal and opposite force. So that, for example, P is the axial force. What exerts that axial force on the right-hand side of this beam? Well, the left-hand side of the beam does. Right? As I make that cut, if it's trying to pull to the right, then the left side's not going to let that happen, so it's pulling back to the left. And so if I do that, then there must be a force in this direction equal to P, but opposite direction. There must be a force in this direction, so equal to V, but the shear force here is going to be down instead of up. And not that Newton really thought about moments, but there's going to be an opposite moment, M, same magnitude, but the opposite direction. So Newton's third law becomes really important here. Equal and opposite forces, and in this case, equal and opposite moments. And so we're going to be interested in examining what those moments are and what those forces are at the cut, right, at the cut. All right, so we'll take a look at an example of that in the next video, and then we'll kind of extend those ideas from there. Thank you. If you have any questions, please leave them in the comments below.